Hi, welcome to a video podcast on double slit interference. I'll start off by just imagining we've got an incoherent source of light, like a light bulb, and that's producing white light, and the waves will be very jumbled and mixed up, and they will not be monochromatic. So we might start by putting in a filter, so only let one wavelength of light through, and we might have a single slit for the light to pass through. The light will diffract through that single slit, and then we can have a pair of slits, and the light both those slits must be illuminated by the light from the single slit. The light here will be coherent, and the two sources, the two slits, will now produce coherent light. That means that either they both produce a crest at exactly the same time, or there is a constant phase difference between them. What would we see on the screen? We would see a set of bright fringes, multiple lights and darks. Now, there's a different video podcast which explains how this pattern forms. Each of these bright spots is the same width. They might be slightly dimmer at the edges than they are at the centre, and again we can represent this as a graph of intensity against angle, and each one of these red spots is a separate little peak. Notice they're not brilliantly defined, it's going down just to dark for a moment, so it can be a little bit difficult to measure exactly the fringe spacing. I'll just quickly do the maths of the fringes. So again, here are our fringes on our screen. The equation is lambda equals WS over D, all measured in metres. Lambda is wavelength. S is the distance between the centres of the slits. W is the distance between the centres of the bright spots, and D is the slit to screen split distance. And you should be aware of how changing things in this equation will change the resulting pattern. So if we increase lambda, the wavelength, maybe going from blue light to red light, keeping S and D constant, then W, the fringe separation, must increase. If we keep D and lambda constant but move the slits closer together, because these two numbers multiplied together must give the same answer, if S decreases, W increases, the fringe spacing will increase. And lastly, if we increase the distance from slit to screen, keeping S and lambda the same, W will increase because the ratio of W to D must stay the same. I hope that helps you. Thank you.